Imagine a time when we are just excited to go out of my classroom. That is a scenario. We are very excited. So who are you? You are the inside particles of nucleus called nucleons. And that classroom is unstable nucleus, radioactive nucleus. You try to get out, you try to get free. That is called radioactivity. And the property with which it happens is called radioactive emissions. So let's understand of what radioactive emission is. Radioactivity is emission of high energy particles or rays together. So it was discovered, hey buddy, what's up? But you discovered it, yes, your name is Henry Becquerel, I know that, but you discovered it by mistake, using uranium salt over photographic. But any which ways, after studying the whole idea, he told that atomic mass number more than 82 are radioactive. They are unstable, they cannot sustain. So radioactivity is defined as that phenomena of spontaneous emission, bursting from the radioactive substance is called radioactivity. So the whole idea of radioactivity comes or narrows down. It depends on the property of atom. Hence, it is unaffected by the chemical or the physical changes. It is a nuclear phenomena. Okay. So radioactivity, being a nuclear phenomena, results into some kind of decay called as radioactive decay. What exactly is radioactive decay? You will come to know in my next module. Well, radioactive decay, however, it has two parts. First, to understand what are the particles, and second, to understand what kind of nucleus will it transcends to. So second part in the next module. In radioactive decay, we first have alpha decay. Now when I talk about alpha decay, what is emitted? Helium, that is called alpha particles, or the helium nucleus, something like this. Okay, here plutonium giving rise to uranium along with the emission of alpha particle, that is the alpha decay, just for the sake of example. Now when I talk about beta decay, that means what is given out is nothing but the emission of high energy electrons, also called as beta particles. So this is what my entire beta decay looks like. So radium giving rise to actinium. So that is what it is. Now what about gamma? Gamma, it's just an energy. It's a photon having no mass, no charge whatsoever. So plutonium will give rise to plutonium only, but this plutonium will have less energy compared to the previous plutonium. Simple enough. Now, for radioactive decay, let's understand what happens in alpha. So for example, an X having mass number A and atomic number Z, when it emits alpha particle, that is 4 and 2, it gives rise to a new particle. That new particle is called Y, having 4 less number of nucleons and 2 less number of proton. So whenever an element emits an alpha particle, its mass number decreases by 4, atomic number decreases by 2. Please remember this. Very useful for the numericals. Similarly, the element when it emits beta, okay, electron, negative charge electron, okay, mass number 0, charge is -1. Your transcended nucleus or the atom will have same mass number, but its atomic number would have increased by 1. Clear enough? So that's what beta decay was all about. Coming towards the gamma decay. In gamma decay, whatsoever, because it's a photon, no charge, no mass, the mass number and the charge number of the new nuclei is same as the parent nuclei. So what is emitted is nothing but just the energy. So this is what decay is. So now if I talk about properties of these alpha, beta, gamma rays, first is alpha is positive, beta is negative, and gamma is no charge, neutral. Now you talk about 2 unit of charge. Here we have -1 unit of charge, and there is no charge again. Simple enough. They are deflected by electric field. They are deflected once again. Who? Beta particle. And these they are not deflected. And whose deflection is high? The high will be of that deflection who are very lighter. That means beta rays get highly deflected compared to alpha rays. Now, ionization power. What is ionization? Knocking off the electrons. Alpha particles are heavy. So when they pass, they make sure all the electrons are taken out. But beta on the other hand, we beta is just a typical kind of person who just walks around, and if he tries to take even something, nothing comes out of it. And that's where my gamma rays come into place. Nothing to do. So the penetration power or the ionizing power is very less. Now you talk about velocity is lesser than the velocity of course he's big fat. His velocity will be of course less. And what about beta particle? Somewhere around the velocity of light. But gamma ray is a light. Now, the penetrating power, who is highly penetrative? The one who is very sleek. Why? More the size, it cannot penetrate inside the body. So alpha particle has less penetration power. As you can see, alpha particle can hardly not even pass through paper. What about beta particle can pass through hand also, but not through the metal sheet. And what about gamma? Be it metal sheet, be it water, be it your concrete, only it cannot pass through lead. So that's what the penetrating power of alpha, beta and gamma rays is. So anyway, yeah, this entire particular animation, no, not problem. The same thing is getting repeated. Now, the whole idea is they affect photographic plate. Yes, they do. Even they have the greater effect on alpha rays. Yes, they affect photographic plates to a little extent. Who? Gamma rays. Last but not the least, atomic number decreases by 2 units and mass number decreases by 4 units. Here atomic number increases by 1 and mass number remains same. Ellappo. So that's where we understand the entire ideation of properties of radioactivity. Thank you.